Hello, hello. Mic check. One, two, three. I hope I am audible to all of you. Just a second. I'm checking something. I'm trying to see if I'm live. Hello, hello. Checking. Check, check. Okay. I can. I do see I am live. So, welcome back, everyone. This is going to be the second stream of the day where we contribute to the open source repository Jaeger and potentially uh, get selected to the LJX program with and win some money in the process. But I'm just joking. Uh, the learning is the bigger goal over here. So if you remember where we stopped in our last stream, we set up the repo in our local, the UI, and ran the Jaeger Docker container, uh, Jaeger Docker container, which our UI will, call so that it can get uh, uh, the data to display, the trace data to display, basically. Now, if you remember, we had to set up, we asked this question to uh, Gemini, and it explained why we have to set up run Jaeger as a container and create the UI as well. So I'm sorry, I'm rambling. I hope I'm audible now because the I just watched my previous stream and most of the time I'm just mumbling and what I'm saying is not properly audible. So I apologize for that. I will try to talk more clearly from this stream onwards. So if you see this hot rod, uh, yeah, so this hot rod is basically an application which will, um, send us the trace data which will be visible on our UI. Once we set this up, we'll start looking at the issues to see if we can contribute to any of them. And yeah, this is what it is. Let's see. My mastering distributed main tutorial. Jaeger comes with a application called Hot Rod. I have previously published an article. Okay, that's the one that uses Hot Rod and Jaeger to demonstrate capabilities of distributed tracing, Jaeger, and open tracing. There is also video recording of this over here. Um, okay, before we proceed, let me just set up this locally. Set, or rather, set this up locally. Close all this. I think we need just two terminals. So where is the delete button? Okay, there it is. And open source Jaeger UI CD Jaeger, and then npm start. This is just testing. I'm just testing something just to see. Okay, it's running on localhost. Checking. Let's see if this loads. Meanwhile, where did that go? Getting started. Where was it? Open source. Where did we store? Jaeger architecture or contributing guidelines. Which one was it? Where we basically had the Docker run command, certificate of origin. Oh, Where was that? Error loading traces. Okay. Oh, here it is. So this is our background. Okay. Meanwhile, just give me a second. I need to show you guys something. Window capture. I'm just setting up something. I want to show you guys the Docker screen as well. Docker screen. Okay. And let me open Docker desktop. Once Docker desktop is open, I'll set the screen and okay, so the Docker desktop should be visible. So let us start up, and what we will do is we will copy this command and paste it in our VS Code, which is over here. Let this backend start. Meanwhile, we'll stop this. Okay, let's see if the image was found this time. Because we did run the Docker command previously as well. We'll git commit. What the hell? Okay, let's go here and start jaeger. VS Code. Now you see the browser. Go to the browser and refresh this. Did I open this tab? I do not remember. This is the contribution guideline. Okay, we'll look at it in a second. So what was it? Localhost 1686. Okay. Okay, we are set up. We are all set. Now, just for a second, let's make a documentation. Uh, okay, first for our Windows setup, what did we do? We did follow this git clone and npm use. At the npm CI, we faced an issue because of Windows. As you can see from here, where was it? It was here, right? In this chat, basically, we were talking about the npm CI command not working. Okay, which is here. And it had explained to us how we have to run these two steps. Uh, the technical deep dive, the claw problem in Unix environment, because it was using this wildcard, the way it is handled in Windows and the other one is different. So I need to paste this. I need to paste this here. And now what I do is, okay, why did I start doing this? Because at the npm CI step, we were facing issues. Uh, da, da, da. Repo and change directly into it. Oh, okay. I didn't do the fork step in the first place. So, okay, let's do that. Instead, I cloned the actual repo. Mm, you know what? Let this stay here. and I'll say Docker stop Jaeger. Okay, it stopped. This also should have terminated. Yes. Okay, now what I want to do is I directly cloned jaeger-ui. So what I'll do is clear this out and go here to code. The contributing the open. Ah, I already have it open. Did I create a new tab? Excuse me. Where is that fork? How do I fork a repository? I think here, right? Create a new fork. Repository, copy the main branch only. Uh, okay, that's fine. We'll copy the main branch only. Okay. Okay, now we are in the fork. Now what we will do code, copy this. Here we go. Should I delete this or so? Let's delete it. We didn't do anything. Jaeger UI. Okay, we delete it. Let it delete. Meanwhile, we'll do git clone and okay, continue. It takes quite some time to delete, huh? Okay, what happened? What was that? Oh, wait. Cool. It's deleted. Now let's clone our fork into. Uh, we didn't mess up anything, right? We had just cloned it and we just deleted the clone. Nothing would have happened. Now I cd it into Jaeger UI. What were the steps to contribute? cd nvm use nvm use now using and instead of npm ci, let's try npm ci. Hmm. If this errors out this time as well, we'll have to use those two commands which I had in Notepad. Meanwhile, I will ask AI to the raw file. Give me give me what? Give me a readme for my own understanding of the setup process similar to below, but instead of the npm CI command, add those two commands of which I had to run in order to uh, overcome the complications of git bash on Windows. Is that a process similar to, but instead of npm CI command? Okay. Oh, I hope it's. Wait. Give it to me. Give it to me in .md format. Okay. Meanwhile, we'll check. Yep, it ran into those two errors. So what we will do is we will go to Notepad, run the first command. Or what? Oh, I have to go to packages and Plexus and now paste it and run. Excuse me. Okay, is this generating for me? It's not giving me markdown. VM start, Docker run, table, photo. It didn't understand my query. Okay, or whatever. Okay, the first command ran properly. Second command, run this while where was that? Getting started. Copy this. Let's clear this out and start the backend. Now what do? We npm start and it should start in 5173. Close both these tabs. Hmm. I hope I am. Okay, it is. It is working. Oh, again, we did this mistake again. We did the same thing in the first stream as well. We were we ran the npm start in the wrong. Okay, there we are. In the wrong directory is what I was saying. Is it open? Oh, let's just open localhost. Let's open this and localhost 5173. Okay, are both working? Yes, both are working. So, okay, we need to proceed further now. Git clone of your Okay, wait. Let me just ask this question. Uh, I cloned. This is a very stupid question, but I mean, I just have to ask this. I cloned a project to my local repo, local machine, and deleted it. Hope it will not affect the repo which I cloned from. I mean, I do understand that we will not have access and stuff to contribute to the main, what do you call? Yeah, okay, I'm safe. I'm sorry if that was too stupid of a question to ask, but for some reason it was bugging me. Okay, let's proceed forward. News, this. Backend, everything is done. Starts development, runs the test, run test for a specific file, run lint. Okay, there was a document where they were talking about branches pointed to. This was the one. What is this? Contribution guidelines, and what is this? Contributing. Okay, how to contribute, making a change, assigning rules, contribution workflow. We recommend the following setup. Go to the respective Jaeger repo on GitHub and create a fork using the button. Okay, this is done. Select a destination org where you have to write. Okay, that is done. That's my personal. This one. I have Jaeger in my personal now. Personal GitHub. This is this one. Git remote. Okay, wait. Oh my God, we had to set up this hot rod, right? I got sidetracked. What happened? What the hell? Uh, okay, let me take a breather. I'm, all over the place. I just need a second. What do we want to do? We want to uh, create slash host the hot rod app so that we can see some traces on our UI. Okay, this is item number one that we want to do in this stream. Item number two is um, what do we do? Explore the traces that are visible from the app. I'll just call Hot Rod HR. And three, uh, go through the issues and try to contribute to one. Okay, I think this will be the agenda. Now, our target is to point one, create host the hot rod app. Okay, now where is that? It is this one. Skeleton, let me close. To contributing guidelines, I think I have to open. Contributing guidelines, let me put it here. See, I have to open. I knew it. Contributing guidelines. These are the two Jaeger UIs. Do I need these? I have to close them. Called Hot Rod. I have previously published. Okay, let's open both these tabs and see what they are. Oh, okay. What is this? Jaeger. Oh, it's in Hot Rod. Okay. Uh, do I need to set up? hot rod application in my local. Uh, will it help in some manner for the UI contribution that I am planning to make? I need to make code changes. It is almost impossible to verify your. Okay. Okay. Requires a Go. Oh my God, I don't have Go. Okay. Open standard for instrumenting applications and OSS packages for distributed tracing and monitoring. In this post, we explore the features and capabilities of open tracing using a demo application Hot Rod from Jaeger, a distributor that recently donated system. Recent donated by Uber Technologies too. Okay. The presentation is structured as a walkthrough tutorial showcasing how can be applied in practice to monitor a microservice-based architecture and perform root cause analysis of performance issues. It also emphasizes the key feature of open tracing. Being a vendor-neutral API, it allows other open source frameworks, such as those used for RPC, implement distributed tracing without locking themselves to a single vendor. Contains no explicit use of around the RPC calls. Instead, all information comes for free from open source. Is implemented in Go. Jaeger backend is with the Docker installation is required. The complete source code is available over here. Okay, then I can close this tab. It is the same thing. Installing Docker. I have Docker engine, so I don't think I need this. Already installed. If you don't have, please go ahead and do so. Windows. Open the MSI file. Download. Where is the MSI file? Okay, it's here. Does it change? Managing listening for how to check out the source. Okay, wait 1 second. I need please see the instructions on how to download and run both the Jaeger backend and the Hot Rod demo app. Introduce the Hot Rod app and its features. Use the tracing UI to understand the app's architecture and data flow. Compare standard logs versus open tracing logs. Identify sources of latency and errors in call graph. Okay, so Jaeger to collect and view the applications. Okay, this all-in-one latest. I already have a Jaeger backend running. This is in the same 1686. Once the container starts in the browser, access the Jaeger UI. The container runs the Jaeger backend with an in-memory store, which is initially empty. So there is not much we can do with the UI right now since the store has no traces. Let's generate some status. Okay, this I've already set up as part of the first setup where we ran this command, if you remember, the all-in-one configuration, where both the collector and what is it called? Okay, this is just a tiny detour. Texture choices via Kafka. What was it called? All-in-one collector query. Collector query, both are in one. So that's what that was. Let's go here. Meet the Hot Rod app. Let's download, run it, and see it. Now the question is, do I again create a fork? I think that would be the safer thing to do. Uh, do, do, do. Uh, this is useless. Tracing. Okay, first let's install Go. How to install multiple versions? Hmm. Okay. Okay. 1 second. I need to stop sharing. Ah, see, now I've become professional. I have a be right back screen. Huh? Anyway, okay, what does the document say? I downloaded it. Verify that you can change the location after installing. 1 second, I'm just installing Go. Next, 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 install. Yes, it is installing Go. So meanwhile, let's continue reading the documentation. Uh, Download the MSI file. Let's see. I need to create a fork of this starting from version 1.3. Okay, let me document this somewhere. Uh, Create a fork. Okay, am I displaying my entire window? Okay, create a fork of, if you can see my notepad, create a fork of Jaeger and set up the hot rod app. Uh, Make docs for this. I'll create a, documentation for this and upload it in my GitHub repo. Uh, Meanwhile, is this installed? Okay, those git bash. The command was go version. Go version is installed. Now, ride sharing app, let's download and run it. See up to date. Let's navigate to the main service. Okay, 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 okay. Before we go there, let's do. Oh, this is Uber Jaeger. Okay, that is strange. 1 second. Source, Jaeger, architecture, mentorship. Hmm. Okay, what am I doing? I came in from here, right? Contributing this. Sorry, getting started. Where is the hot rod application? Okay, here. Okay, I came in here and I clicked on this. Okay, not this. I'm just duplicating the tab. It was this, right? I remember seeing Jaeger. Ah, Jaeger tracing Jaeger. And here I saw Uber Jaeger. This is what I was confused. Which one do I clone? Ah, does it matter? Come on. Which one do I fork? I mean. Oh, can I? No, I'll have to clone the entire Jaeger repo. Or rather fork. Okay, let's go here. Okay, let's read. Okay, Go is downloaded. Architecture I don't need. Here it's pointing Jaeger tracing Jaeger.git only. CD Jaeger, go run, and we are running this. So Uh, Let me fork Jaeger also. I mean, I know I'm repeating the same thing again and again, but please bear with me. Jaeger tracing Jaeger, fork, Jaeger is available. Okay, copy main branch only, that's fine. Marimo Jaeger. Okay, now I have this. I go here, copy. Now the question is, let me make it in the same folder, it doesn't matter. Open source, get clone, Marimo Jaeger. Now I've cloned Jaeger also. I need a second. I am so sorry, I had an important call to attend to, and now I'm back. So where were we? We were cloning the repo, right? Am I sharing the entire thing? Oh, sorry, I'm not sharing it yet. Okay. Yeah, Jaeger is installed. Now, what was the next step? Sorry, this. What happened? Okay, Jaeger is forked. Okay, where is the medium documentation? Am I? Oh, that's. What was it? This. Ah, I must have closed that tab. Oh my God. Okay, it is visible. Please load. Ah, okay, here it is. Sorry, sorry. Git clone. Let me see and then what was it? Go run. Oh, delete start to this. It's I'll have to restart my VS Code in the VS Code. Oh, I hope the terminals didn't terminate. Again, please bear with me. Oh my God, the terminals terminated. Okay, let's do it again. CD jaeger-ui and it was npm start, and in the second one it was this one, the second terminal starting my Jaeger backend. Again, we have to verify localhost, localhost 773. Okay, we are good. Now copy this, and in the third terminal we run the Go application. Cannot find the path specified. Ah, okay. CD. And while this installs, just give me a second so that I can verify that the stream is still going on. Hello, hello. Yeah, the stream is still going on. Okay, with that out of the way, where were we? We were. Okay, let's continue reading the documentation. Uh, Work to this app. Ah, this is the same thing which happened. Let me just allow it for now. And what was it? Oh, on dev firewall. Think of Windows firewall. What did it say? I cancelled the pop-up. Alone app. Okay. Windows allow. Now it was. Main.exe. Main.exe. Let me make this private. Why am I not able to edit this? Okay, sorry. Let me just make this private. I don't want any calls going out to the public network. Okay, that was that. Now let's see if this gRPC, okay, edit, documentation go. Close both of these for now. Starting from version 1.3, the Jaeger project includes a Docker image for the hot rod example. See the README, which is a good for running a quick test of the tracing app. But in the post, we will also be making small changes to the source code. So running from source is recommended. The all command tells it to run. We did make a fork of this, right? Okay. So we can make changes over here. That is not an issue. Uh, mm, mm, I'm just checking something. This is showing all. Okay, we did clone this only. I hope we cloned the local version only. Good quick test for running a tasting app. Okay, small changes to the source code. So running from the source is recommended. The all command tells it to run all microservices from a single binary. In the logs written to standard out, we can see these microservices starting several servers on different ports. Is it? Did we see? Starting, yep, 8081, 8080. Okay, cool. Um, let's navigate to the main service at here. Okay, now what? Hot rod. We have four customers, and by clicking one of the four buttons, we summon a car to arrive to the customer's location. Perhaps to pick up a product and deliver it elsewhere. Once a request for a car is sent to the backend, it responds with the car's license plate number and the expected time of arrival. Your web client is 9323 1268. Okay. What is click on a customer name above to order a car, arriving in 2 minutes latency. There are a few bits of debugging information we see on the screen. In the top left corner, there is a web client ID. It is a random session ID assigned by JavaScript UI. If we reload the page, we get a different. Okay. In the line about the car, we see a request ID. Do I click on something? Where's request ID? Okay, yes. Uh, Rachel's floral design. Okay. We see a request ID. It is a unique ID assigned by JavaScript UI to each request it makes to the backend, composed of the session ID and the sequence number. Okay, session ID and the first request. Debugging data is measured by, okay, this additional information has no impact on the behavior of the application, but will be useful when we look under the hood. Okay, the architecture. Now we've seen what the application does. We can ask how it is architected. After all, maybe all those servers we saw in the logs are just for show, and the whole app is simply a JavaScript frontend. Okay, rather than asking someone for a design document, wouldn't it be great if Jaeger could build the architecture diagram automatically? By observing the interactions between the services. That's exactly what Jaeger can do. Okay, cool. That request for a car we executed had provided enough data. Let's go to the dependencies page and click on the DAG tab. This is in the Jaeger UI. Localhost 5173. Is it? Where is dependencies? System architecture. Or was it in the Hot Rod app only? No, it's not in the Hot Rod app. For binary running 4 microservices and apparently 2 backend storages. MySQL Redis. Where is this? What is the DAG? Oh, I am in dependencies. Dependencies, backend, small graph. No, this is large graph. No, 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 no. What am I doing? Compare, search, Jaeger. Okay, let me do one thing. Can I copy the whole thing? Oh, it copies pictures as well. Wherever we were here, it does say Jaeger UI though. Look up trace ID. Look up by trace ID. Yes, this is Jaeger UI. Okay, Jaeger UI. Okay, let me read this. Rather than asking someone for a design document. Okay, is there someone in the chat? No one in the chat. Okay, I'm on my own. Rather than asking someone for a design document, wouldn't it be great if Jaeger could build the architecture diagram automatically by observing the interactions between the services? That's exactly what Jaeger can do. The request for executed had provided enough data. Let's go to the dependencies page and click on the DAG tab. Empirically constructed service dependency diagram. Or was it, let's see, this Jaeger system architecture. Oh, it came to this Jaeger. Oh, there's nothing here. Oh, I just had to refresh it. Okay, okay. Uh, yeah, I'm an amateur. Please bear with me. Dependencies page and click on the DAG tab. Okay. Running 4 microservices, one, two, three, four, and 2 databases. Okay. The storage nodes are not actually real. They are simulated by the app as internal components, but the top 4 microservices are indeed real. We saw each of them logging a network address of the servers they run. Okay, the front-end microservice serves the JavaScript UI and makes RPC calls to the other 3 microservices. Okay. The graph also shows the number of calls that were made to handle the single request for a car. Example, route service was called 10 times and there were 14 calls to Redis. 10 times and 14 calls to Redis. In our case, the route service was called 20 times. 27 calls to Redis. Okay. I don't know why, but okay. The data flow. We have learned that the app consists of several microservices. What exactly does the request flow look like? It is time to look at the actual trace. Let's go to the search page in the Jaeger UI. Under the Find Traces caption, the services dropdown contains the names of the services we saw in the, okay, the services one. Let's go to the search. In the service, yes, I do see. Can I okay, no, I need this. Uh, because we know that front end is the root service, let's choose it and find and hit find traces. Okay, let's choose front end and hit find traces. Now what? Now I should see. The system found one trace and displayed some metadata about it, such as the names of different services that participated in the trace and the number of. Okay, wait. The system found one trace. What do you mean one trace? Okay, I think this is one trace. This front-end HTTP GET dispatch that we see here. Oh my God, I have multiple traces. Why do I have multiple traces? 8 minutes ago, 7 minutes ago, 3 minutes ago. Uh, Why do I have multiple traces? Okay, look back. Let me do last 5 minutes. Find traces, dispatch and config. Can I reduce this? Okay, let's read the documentation. 51 spans, or did it 39? Okay, it's the same thing, just it looks like an older UI. Some metadata about it, such as the names of the different services that participated in the trace. Okay, here it. Why are there two errors? Let's take a breath. Let's come back. Services that participated in the trace and the number of spans each service emitted to Jaeger. Number of spans emitted to Jaeger. The top level endpoint name is displayed in the title. Okay. 1 second. Let's go here. What is the this is query is span Jaeger. Represents a logical unit of work within a distributed system, such as a HTTP request, database query, or a service call. Okay, it captures essential details, including an operation name, start time, duration, and optional metadata like tags and logs. Okay, spans are fundamental building blocks of a trace, forming a directed graph DAG that illustrates the flow of the request across multiple services. Okay. Each span is uniquely identified by a span ID. Okay, we know what is a span now. 39 spans, damn. Okay, uh, let's continue. Where were we? Okay, this is we completed Jaeger as number of spans. We were in this line. Okay, the top level endpoint name is displayed in the title bar. Okay, on the second, on the right side, where did I get second from? I'm starting to not be able to read. Okay, let's get back on track. On the right side, we see that the total duration of the trace was that this is shorter than 782 we saw in the hot rod UI. 732, 709. Okay. Let's go back to last 30 minutes. That's why I wanted to. Let's go back to last 5 minutes. No traces. Okay. Let me refresh the page. Let me click one. Okay. Here. Find traces. Okay. I found. Okay. 724. What did it say here? 729. Okay. This is shorter than we saw in the hot rod UI, which is not surprising because the latter was measured from the HTTP client side by JavaScript, while the former was reported to the Go backend. The difference between these numbers can be attributed to the network latency. Okay, let's click on the trace title bar. So I have to click on the dispatch one. Okay, I get something like this. Hmm. Click on the title bar for trace as a time sequence of nested spans. Okay, each of these is a span, where a span represents a unit of work within a single service. Of work within a single service. The top level span, also called the root span, represents the main HTTP request from the JavaScript UI to the front. This big span, the front end, that is okay. Where were we? Single service. The top level span, root span, represents the main HTTP request, which in turn is called the customer service. This is called the customer service. Okay. In our case, it is this front end is called the customer service. Okay, okay, makes sense. Which in turn service, which in turn called a MySQL database. Customer service, which in turn called a MySQL database. Okay, okay, makes sense. The width of the span is proportional to the time of a given to the time a given operation takes. It may represent a service doing some work or waiting on a downstream call. Okay. From this view, we can see how the application handles a request. The front-end services receives the external HTTP GET request at its dispatch endpoint. The front-end services receive the external HTTP at its dispatch endpoint. The front-end service makes to the customer endpoint. The customer endpoint executes a SQL select statement. The results are returned back to the front-end service. Then the front-end service makes an RPC request to the driver service, customer, and MySQL. Okay, till here we the front end, the dispatch services. This has the details of the HTTP response which came from the front end to the dispatch service, and then we again in turn call the customer service, and the customer service calls the MySQL. It runs a select query. That's what those explanations were up until point number 3. Then the front end service makes a RPC request find nearest to the driver service. This one, it to find nearest to the driver service. Without drilling more into the trace details, we cannot tell which RPC framework is used to make this request, but we can guess it is not HTTP. Okay. The driver service makes a series of calls to Redis. Some of those calls are highlighted with pink background indicating failures, which was also the case with us. You just see an exclamation mark. Okay. Indicating failures. Where were we? We were here. After the front-end service executes a series of HTTP GET requests to the route endpoint of the route service, finally the front-end service returns the result to the external caller. What was that? I didn't understand that. Service executes a series of HTTP GET requests to the route endpoint. Yes, there is a series of HTTP requests to the route endpoint. Finally, the front-end service returns the result to the external caller. In the timeline, it expands to show more details, including the span tags, process tags, and logs. Let's click on one of the failed calls to Redis. We see that the has a error equal to true. Failed calls, error equal to true, uh, error equal to true, and what was it? which is why the UI highlighted it as failed. We can also see that it has a log statement that explains the nature of the error as Redis time dot. Okay, we can also see the driver ID that the driver service was attempting to retrieve from Redis. Driver ID, driver ID. Yeah. Where is it? Driver ID. It was trying to retrieve from Redis. Okay. We can also see the driver ID that the driver service was attempting. Okay, this contextualize now. Now I have a pretty good idea about what the application does, if not exactly how it does. For example, why does the front-end service call the customer endpoint of the customer service? Of course, we can look at the source code, but we are trying to approach this from the point of view, application model. Okay. Okay. One direction we could take is to look at the logs, the apps write to std out. Oh, you mean this? Oh, okay. It is indeed difficult. Yes, it is quite difficult to follow the application logic from these logs. And we are only looking at the logs when a single request was executed by the application. Imagine many concurrent requests going through the system. Yes, it's going to be a nightmare to debug all these things. The logs become nearly useless in that case. Yes, so let's take a different approach. Let's view the logs collected by the tracing system. For example, click on the root span to expand it and its logs. Click on the root span to expand it and its logs. Okay, okay. Hmm. This view shows only the logs that happened during the execution of the root span. We call them contextualized because they are captured in the context of a specific request. Yes, and even specific span within the trace. With the specific span within the trace. We have earlier seen an error log from the timed.redis call. In the std out, it would have been mixed with a lot of other statements, but in the tracing system, it is neatly isolated to the service and span where it was relevant. Drill into the behavior of the application without worrying about the logs from other parts of the program or from other concurrent requests. Okay, okay, that makes a lot of sense. Hmm. Yeah, so what they were basically trying to say is in the these logs, it is very difficult to make out uh, which log to debug. So basically, we did see some of these Redis errors, and the reason for this is the Redis timeout. But how do we differentiate between this front-end span and this Redis span? So this UI visualized way is a better way to look at things. So that we can see what are the details, what are the response times, what are the other services that this front end service called, what are the endpoints it called, and yeah, basically to differentiate that. I mean, that was pretty self-explanatory. Okay, shows program with a contextualized. Okay, uh, the front end span, the context is basically this dispatch service had these response times, OS type Windows, and the status code, and all those things. Okay, okay, okay. I'm basically explaining this to myself. Sorry. Um, yeah. Do I have anybody in the chat? No one in the chat. Okay. Span tags versus logs. Let's expand a couple more spans. Okay. Customer HTTP. It was customer HTTP and MySQL. These two things only were expanded. SQL select, right? That's yes. Slash customer SQL select get slash customer. Okay. In the customer span, we see a tag http.url that shows the request at the customer endpoint had a parameter customer equal to 123. Query parameter customer equal to 123. In the MySQL span, we see a SQL.query tag showing the exact SQL query that was executed. Customer ID, where customer ID equal to 123. Okay. How do we decide if this data should go to the span tag or span logs? Span tag, how do we decide whether this goes to the, it goes to the tags or the logs section. Okay, okay. The Open Tracing API does not dictate how we do it. The general principle is that information that applies to the span as a whole should be recorded as a tag, while events that have timestamp should be recorded as logs. Events that have timestamp should be logs. The span as a whole should be a tag. A specification repository defines semantic data conventions that prescribe certain well-known tag names and log fields for. Okay, the scenarios. Instrumentation is encouraged to use those names to ensure that the data reported to the tracing system is well defined and portable across different tracing backends. Defines data conventions that prescribe well-known tag names. Instrumentation to use those names to ensure that the. Okay, that's just basically telling us to follow the conventions so that throughout your organization and throughout your infrastructure you have like a proper nomenclature that you follow. Okay, that makes sense. Identifying sources of latency. So far we have not discussed the performance characteristics of the hot rod application. If we go back to the screenshots of the trace, we can easily make the following conclusions. Cur- Customer service is on the critical path because no other work can be done until we get back the customer data. One second. Duplicate system architecture. Okay. Let's come back here. The call to the customer service is on the critical path because no other work can be done until we get back the customer data, which includes the location to which we need to dispatch the car. Customer MySQL. Okay, it is a critical path. Okay. The driver service retrieves the 10 nearest drivers. Driver service. Okay, 4 times. So it has called 41. Okay. So basically, the number 41 that I see is I have executed this. I have clicked one of these buttons 4 times since the start of this. So that's why I think there are 41. Um, or no, I've executed it 3 times. Uh, Maybe there are more than 10 drivers. That's why this number is 41. Okay, okay. The 10 is given the customer location and then queries Redis for each driver's data in a sequence, which can be seen in the staircase pattern of Redis get driver spans. Okay, let's see. We close this as well. Staircase pattern. The driver service keeps calling Redis to retrieve a bunch of drivers. Okay, okay. Staircase pattern. Okay, makes sense. Hmm. Redis, okay. The calls to the route service are not sequential, but not fully parallel either. We can see that at most 3 requests can be in progress, and as soon as one of them ends, another request starts. This behavior is typical when we use a fixed size executor pool. The calls to the route service are not sequential. The calls to the route service are okay. There are a bunch of calls to the route service and they are not sequential. What does this mean? But not fully parallel either. We can see that at most 3 requests can be in progress, and as soon as one of them ends, another request starts. This behavior is typical when we use a fixed size executor pool. Okay. So you see, in the documentation, they have said. At most, three requests can be made in progress. But if you see here, um, one, two, three. Yeah, three requests. Okay, three requests at the time, and one of them ends, another one starts. So basically, where this ends will be the start of this. I hope that makes sense. This one, wherever this 55.15 milliseconds ends, will be the start of this approximately. Am I right? Yeah, more or less. So that's how this works. Okay, that makes sense. Three requests at a time. To the backend, let's go to the hot rod UI, click and click on one of the buttons repeatedly and quickly. As we can see, more requests. Okay, hot rod. Okay, let me come back here. Uh, Last 5 minutes, find traces. I clicked on it multiple times. Okay, to the medium dock. More requests are being processed concurrently. The longer it takes for the backend to respond. Is my mic? Okay, I am still speaking. The longer it takes for the backend to respond, let's take a look at the longer it takes for the backend to respond. Is it? Oh, 729, 648. Okay, I do see a trend of increasing response times. Okay, okay, makes sense. Case of the longest request, we could do it in two ways. We can simply search for, oh, I'm just halfway through the documentation. Okay, there seem to be a lot of pictures. Okay, what's the time? I am losing interest, but okay, I don't think we will be able to do the third point. Only we will just cover the first 2 points for today. Let's see how it goes. Maybe I'll come back and start a third stream sometime in the night, but uh, yeah, I don't know. Let's take a look at the trace of the longest request. We could do it in two ways. We can simply search for all the traces and pick the one with the highest latency represented by the longest cyan colored title bar. Okay, dispatch. I don't think there is the longest cyan colored 1.58, 1.51. I think it orders by maximum only. So let's click this. Okay, so this cyan is what they're talking about. You see the one with the 1.82 is full, the one with 1.58 is a little less. This cyan is this greenish blue color, whatever. Another way is to search by tags or logs in the span. The root span emits a final log where it records the winner driver ID as a field. The root span winner driver ID as a field. And driver ID. Where is it emitting? Command F driver. They're talking about this dispatch successful. Driver equal to this. Okay. Yeah, we found it out. The Jaeger indexes all spans by tags and log fields. We can find that trace by specifying the. Oh, okay. Driver. It's saying. Oops. Saying copy this. Or click copy. Go back and tag HTTP status code driver. Okay, wait, let me open this in a new tab. So I think I clicked on this. Show more. Driver equal to this. Okay. Driver equal to what did I copy? Down. I copy this. Go to this. Find traces 40 spans 1.67 seconds. Okay. The Jaeger backend indexes all spans by tags and log fields, and we can find that trace. Indexes all spans by tags and log fields. Okay, okay, it indexes all spans. Span is this cyan colored one by tags and log fields. Let's open this, compare it with the 700 millisecond trace we saw earlier. The most apparent difference is the my takes a longer than before instead of 305. Let's expand that span and try to figure out why. Okay. In the logs, we can see that execution was blocked waiting for a log for over a second, waiting for a log behind 4 transactions. Hmm. Duplicate. Uh, I mean, we have to go through this. This has to, um, I mean, this will help when we are working on the UI, waiting for a lock behind 4 transactions. And I go here, I come back. Where was it? Was it search? Let's give last 15 minutes. Front end dispatch, and let's take the one with the least, which was around 729, 933, 639. We'll take this and we'll open the SQL acquired lock. Okay. Okay, we are where we want to be. Lock over a second. This is clearly a bottleneck in the application. But before we dive into that, let's look at the previous log record, evidently emitted before getting blocked on the lock. It tells us how many other requests were already queued for this lock and even gives us the identity of those requests. Okay, so here it says waiting for a lock. Blockers are this 9510.5, 9510.6, 9510.7, 9510.8. Oh, cool. So 5, 6, 7, 8. So these four were holding up the database. So that is why this took time. Okay, that makes so much sense. And if you see the this one, it says acquired lock instantly, 0 transactions waiting behind. Okay, cool, cool. It is not too hard to imagine a lock implementation that keeps track of how many coroutines are blocked, but where would it get the identity of the request? If we expand the previous span for the customer service, we can see that the only data passed to it via HTTP request was the customer ID 392. In fact, we inspected every span in the trace. We will not find any remote call where the request ID was passed as a parameter. So what they're basically trying to say is if we go back, this one, it is saying that these many requests are blocking the current SQL query execution. It's saying waiting for lock. But where is this information coming from? If you go to each of the span, the customer span, front end span, and or the root span, you will not see anywhere these requests or these SQL IDs are being passed as a parameter. So that is what they're trying to say. And to passed as a parameter. This magic appearance of concurrent request IDs in the logs is due to a feature of the standard called baggage. Distributed tracing works because certain metadata is propagated across thread and process process boundaries throughout the whole call graph by the tracing instrumentation using the open analysis. One example of such metadata is trace and span IDs. Another example is baggage, which is a general key value store embedded in every inter-process request. The data is trace and span IDs. Okay. Another example is baggage, which is a general key value store embedded in every inter-process request. Okay. Store session ID and request ID in the baggage before making the request to the backend. That baggage is made available to every service involved in the handling of the request. Okay, okay. Without the need to pass the information explicitly as, okay, what did we learn about? We learned about baggage might be important. Might be, I don't know. Um, I'm just going with the flow. Yeah. Hmm. Single request throughout the, where was I? It is an extremely powerful technique that can be used to propagate various useful information in the context of a single request throughout the architecture without needing to change every service to understand what they are propagating. Okay, the pivot tracing project shows fascinating examples of more dynamic. I think this is another project in the. Uh, where did that go? Was it this? Samples? Is there a pivot tracing? Okay, whatever. Let's continue. Using baggage for dynamic monitoring. In our example, knowing the identities of these requests stuck in the queue ahead of our long tail request allows us to find traces for those requests and analyze them as well. Real production systems, this could lead to the unexpected discovery of a long running request, spoiling a lot of other requests that are normally very fast. Later, we will see another example of using baggage. Now that we know that MySQL call gets stuck on a lock, we can easily fix it. As we mentioned earlier, the application does not actually use MySQL, just a simulation of it, okay? And the lock is meant to represent a single database connection shared between multiple Go routines. Okay, we can find the code in over here. Okay, notice how we, okay, let's see this t.log.log ctx. I don't know Go, so defer, unlock, delay. Notice we pass the context parameter to the lock object. Okay, context.context is a standard way in Go to pass request scope data throughout the application. The open tracing span is included in the context, which allows the lock to inspect it and retrieve the JavaScript's request ID from the baggage. Okay, let's comment out the log statements to pretend that we fixed the code to use a. I'm not going to do this right now. I'm just going to continue reading the documentation. Maybe I'll try it in tomorrow's stream. Or maybe whenever I stream next. Um, DB context uncomment and try hands-on of the code. Mm, Maybe. So maybe I'm not going to do this live. My attention span is really on the edge. Comment out, we fix the code, use a connection pool with enough capacity that our concurrent requests do not have to compete for resources. Decrease the delay from 300 milliseconds to 100 milliseconds. Services config go file, then restart the hot rod app and repeat the experiment. Oh, now the response times are pretty even. Still increases as we add more requests to the button, no longer grows as dramatically as with the single MySQL bottleneck before. Let's look at one of the long traces again. Okay, as expected, where is the MySQL span? Okay, MySQL span is this brown one. stays around 100 milliseconds. Okay, 109 it was. The driver span is not expanded, but it takes the same time as before. The interesting change is in the route calls. Oh, now there are staircase. Earlier the route, am I right? No, no, the route calls. Oh, yeah, now there are staircase. Okay. If you see here, the route calls were like longer and they're not really a staircase. Okay. It's take more than 50% of the total request time. Previously, we saw executing in parallel three at a time, but now we see periods without even a single request running. Clearly, we have contention with other Go routines on some limited resource, and we can also see the gaps between the spans of the front-end service, which means the bottleneck is not in the route service. From the front-end service to the route service, there is a gap. The interesting change in the route was which take more than 50% of the total request time. Previously, we saw these requests executing in parallel, three at a time, but now we see periods. Okay, clearly we have contention with other Go routines on some limited resource. And we can also see the gaps happen between the spans of the front-end service, which means the bottleneck is not in the route service, but in how the front-end service calls it. Let's look at the code in the, okay. This function receives a customer record with address, ETA get routes, customer record with an address, okay. And a list of drivers, which is the address. Customer, okay, this is the list of drivers. The function parameters are these, get routes. Okay, let's just read this. And a list of drivers with their current locations and calculates the ETA for each driver. It calls the route service for each driver using an executor pool. I think this is the core concept. So as long as we have enough executors in the pool, we should be able to run all calculations in parallel. The default value of 3 explains why we saw at most. Okay, that is this. Core routines are cheap. Restart the hot rod and rerun the test. They have reduced. We have to click on the buttons really fast now because the requests return back in less than half a second. Yes. And if you see the routes, they are almost parallel. The calls from the route service are all done. There is no gap from front end to route service. Where's the architecture? Did I close it? Yeah, I closed it. Okay. Front end to route service, thus minimizing the overall request latency. We leave the final optimization of the driver service as an exercise for the reader. Driver service. Oh, this one. The reason this optimization. Okay, we have to figure that out. Okay. Resource usage attributions via baggage. Sounds a bit boring, but comes up in large organizations all the time. When they try to improve efficiency of, say, their hardware usage, there is often a need to measure resource usage and attribute it to some high-level business parameter. For example, the calculation of the shortest route performed by the route service is a relatively expensive operation. Okay. It could be nice if we could calculate how much CPU time we spend per customer. Mhm. Farther down the dependency tree from the point where we know about the customer, and it does not need to know about the customer in order to calculate the shortest route. Passing the customer ID to the route service just to measure CPU usage would be bad API design. Okay, this is where tracing and baggage come into play. Because baggage passes down some of the request attributes uh, from the backend without explicitly writing it in code. I think that's the right understanding, but yeah, we can revise baggage later if we want. In the context of a trace, we know for which customer the system is executing the request. Context of a trace, we know for which customer the system is executing the request, and we can use baggage to transparently pass that information throughout the architecture without changing all the services to accept it explicitly. Okay, and if you want to perform CPU usage aggregation by some other parameter, say the session ID from the JavaScript UI, we can do it without changing the app as well. I hope my mic is on. Okay, my mic is on. Sorry about that. Sorry. We can do it without changing the app. To demonstrate this approach, the route service contains the code to attribute the CPU time. Please from the baggage. In the services file, we can see this code. As before, we don't pass any customer session ID because they can be retrieved from baggage via the context. The update calc stats function uses the expvar package from Go standard library to accumulate and present the results. Okay, we are almost at the end. We can see route entries that give us the breakdown of time in seconds spent in calculation on behalf of, okay, debug was spent in behalf of each customer and some UI sessions. Instrument with open tracing. Okay, we have to complete this. Is a topic for another blog post. Okay, nice. But it is worth pointing out that there is not a lot of open tracing instrumentation in hot rod source code itself. For example, driver service exposes T-channel server created like this. Okay, the only line related to open tracing is passing the tracer in the options. Options T-channel tracer. Okay, the function implementing the endpoint does not have any reference to open tracing either. Okay, this is because T-channel, an open source framework, directly integrates with open tracing, another open source framework. When we create an application, we just need to instantiate a concrete tracer and pass it in. We can see a similar lack of instrumentation in the HTTP endpoints. Okay. In fact, so they're basically saying this open in the source code itself, there is no proper open tracing standards which have been implemented. You can see similar lack of instrumentation. In fact, the only place where the open is used explicitly in this function that simulate Redis and MySQL because they were not actually making any RPC requests. What about vendor neutrality? We stated in the beginning that the applications instrumented with open tracing avoid vendor lock-in to a specific tracing backend. Okay, we leave it to an exercise to the reader to try collecting traces from hot rod into another tracing system. The only place in the application that needs to change is the init function in the package tracing init.co. Okay. Contextualize logs from the application. How do they get to the tracing backend? Does the code need to call the log methods and open the tracing spans directly? In the find nearest function above, we see an example of the log statement. Searching for near, okay, the expression is structured logging API supported by a fast logging library for Go called Zap. Okay, there's apparently a library called Zap, and that is being used over here. There's nothing specific to open tracing here. The trick we are using in Hot Rod is a wrapper around Zap logger that does not expose normal logging methods. Instead, it provides two methods. Returns a contextualized logger for request scope logs, logger for request scope logs. Okay. Log specific to a specific request, such as for intent slash dispatch or something like that. Returns a background logger for logging events that are not scoped to a request, such as application startup sequence. The processes which run in the backend. So we need these two kinds of loggers. Accessing a contextualized logger always requires a context object. Once we have the context object, all normal log methods can be delegated not only to the regular logger, but also to the background one. Okay, let's read this again. Accessing a contextualized logger always requires a context object. Okay, once we have the context object, all normal log methods can be delegated not only to the regular logger, but also translated into the calls to the logging methods on the span. Okay, it's not just for tracing. We have seen how tracing can take on the role of a log aggregation system by presenting the logs in the context of respective tracing spans, while not requiring the application to use separate logging API. Mhm. Excuse me. What about another critical piece of monitoring for microservices, collecting metrics about RPC endpoints? It turns out that instrumentation using often a superset of instrumentation people use a monitoring RPC endpoint. I don't know what RPC endpoints is. Hmm, learn about RPC endpoints, maybe. And when I say maybe, I mean on the stream. I will definitely learn about these topics, but yeah, doing it on stream might be difficult. So request counts, error counts, and distribution of request latencies. Open tracing already captures all these signals, can emit metrics without additional instrumentation. Okay. Tracer Go as an option to emit, debug VARs, collect all endpoints. Okay, just telling us about its features. For example, Jaeger, RPC. Okay. See that there were 24 successful requests to the customer endpoint. Where is it? Debug was, or maybe here. Okay, here, 24 successful requests. Oh, the status codes 2xx, 3xx, 5xx. Okay, are emitted by open tracing instrumentation and the Jaeger tracer. So basically saying that all this information is available over here. Uh, we can find, look at that later. Example from Uber's internal dashboard. Ah, this is an internal dashboard. Okay, all these metrics are emitted by open tracing and he reviewed practical examples of following off-the-shelf instrumentation, monitoring transactions, measuring latencies, root cause, contextualized span, baggage. Okay. For the demo as well as the Jaeger backend is on the GitHub. If something in this tutorial does not work, please open an issue. Hmm, cool. So yeah, I think we are going to stop the stream here. So yeah, in the next stream, let's actually do some coding because I did not expect this to take so long. But getting an understanding of the project is actually one of the things that is recommended in the boot camp. So if you just go to Jaeger's contributing guidelines and one of the documentations, it says as part of the boot camp you need to have boot camp is basically what they are calling it. It's just a name that they have given. It's not like a course or something, but as one of the boot camp tasks, it is important for you to understand the repository, the logic that is implemented in the code, and just get a basic understanding of the tool, the business that they are trying to do. So yeah, so now I think we have somewhat of a proper, you can say, foundation based on which we can actually start looking at the front end code and try contributing to this Jaeger repo. So see you guys in a day two stream, which I might do tomorrow or maybe in the weekend, Saturday or Sunday. I'll try to stream on both Saturday and Sunday. I don't know how long the stream went. It's close to 2 hours, I think. So yeah, thank you guys. I know that nobody is here, but yeah, thank you and see you in my next stream. Bye bye.